Okay, so my name is Veli-Pekka, I'm CTO of 7signal. I will now next cover performance optimization with 7signal Sapphire. I have took one slide from one of my earlier presentations in IEEE meeting this spring about the challenges with wireless LAN networks today. There have been some questions. I was planning to go through these to talk about these challenges because many of these are issues that need to be dealt with when you optimize a network. But due to the kind of lack of time, I will cover one specific question that has come from several sources several times. And it's the mobile network interference for wireless LAN. And I want to explain that and then move forward on the optimization. So we have here mobile base station. We have here, for example, in this case, this could be a wall, like in one of our cases, antenna pointing out this way. Access points with antennas here, having this kind of beam shaped sideways. So this can be a troublesome situation, and when we look at the spectrum, now these signals come from the base station, transmit. This is a lot of power, a lot of gain in the antenna still there. So this might come in pretty strong, like minus 30 dBm, for example. On frequencies like 1.85, 1.15 gigahertz. So these signals hit the receiver of wireless LAN. And wireless LANs do not have filters. So this is our Wi-Fi band here. So these signals hit the receiver as the wireless LAN signals as well enter there. So when you get strong signals to a nonlinear receiver, and the linearity is a function of the signal level here. When you get strong signals from mobile networks, it goes to the receiver, which will compress or get close to the compression point, and it will start generating kind of ghost signals by itself. So this signal doesn't exist. It is the product of mixing these two signals together, and it just lands here. If this is 300 megahertz, so this third order harmonic will land here. It is generated within the receiver. So if you want to measure whether you have this problem, it's normal spectrum analyzer device or normal radio is the best way to do it. If you can see the like energy levels there with the directional antenna, which you can point, for example, here to what's there. So if you start seeing here on the wireless LAN spectrum growth of noise levels, when you point out this antenna which is connected to spectrum analyzer, then you see that the power levels coming from here are so strong that they are probably doing the same here with the access point receiver and clients connected to that. So I know this is a short explanation, but wanted to cover that before moving forward.
What about how much additional dB in the noise floor does that add?
It easily adds, depending how close you go. It's really a function of that. And it can be significant, like 20 dB more.
Oh. At what distance? So I mean, if this cell tower is, you know, outside your building, or is this when you have an in-building cellular?
This case, it was indoor delivery of mobile network, kind of mobile antennas and a wireless LAN network, and we had a problem at 30 to 60 feet distance.
Oh, so definitely in building.
Yes, this was in-building case. So in-building, it can be an issue definitely.
Well, so what about the vendors who are doing 3G, 4G cell offload in the same AP as your Wi-Fi AP?
Sorry, in the same AP.
Yeah, when they're putting licensed frequency radios in the exact same AP that's doing unlicensed.
Like Cisco has a module that goes in the back of the 3600.
It's a problem if the mobile signals hit the receiver of wireless LAN receiver at strong level, and those frequencies align so that the distance of those frequency lands on the frequency wireless LAN band.
I think it's because you have to have multiples. A single one's not doing it.
Okay.
Okay, so I'm moving forward due to lack of time. So those problems, how do they show up? This is an example how they show up. This is a 2 days throughput data. So basically, good throughput nighttime, daytime throughput comes radically down. Of course, there is a load, but it comes a lot down. And it's typical for wireless LAN networks, even though it's not optimally configured, it works. But when you put on load, it kind of rapidly degrades. So you try to prevent this kind of things happening so that it goes down fast. I will move over. I did cover the top-down, bottom-up principle already, but I want to highlight that these KPIs are statistical events, represent statistical nature of the network and service. So that's important. One individual measurement spot might not have any value. It can be caused by anything, but when you look at a lot of samples, you see the trend and you get the overall performance. This is the slide I already partly covered. So you ensure that network is capable of providing the service. With active measurement, with passive measurements, you make sure that clients are capable of utilizing that network, and with SLAs, you maintain the network. We have a pretty kind of standard way to look at the network optimization flow, and this time we are not able to go into this because of lack of time. This material will be available for download, so you can look at the flow, what we suggest there. And we are more than willing to talk with any of you later on about this topic, cover some specific aspects that you might have in your mind. But I do want to show some of the results from Avans University of Applied Sciences. Thanks to the Kees Pronk, network admin there. Kees has been really great help and a lot of courage to let us show data from his network. They have been doing great job with the network. They have been using all the tools, everything there, and they still were experiencing issues with the network. We did an optimization project with them. We adjusted a few settings in the networks, and this material is available as well. But I want to show some of the findings from those tweaks. So we got significant improvements in the overall network performance when we switched off certain things.
VP, could you go back to the other slide and just give us 30 seconds to digest it, because it's pretty important.
Yes.
Before you, if you would.
Which one?
Right where you are, yeah.
Okay.
Just to see the things that changed.
Yes? Okay, so what we did, first of all, for 2.4 band, it's a European area, we moved to 4-channel plan. Secondly, we changed beacon intervals to 300 milliseconds to reduce the overall utilization there. Basically, empty network running a lot of packets, reducing that. We removed B support, disabled a couple of codecs. On the third change, we adjusted power levels. Fourth change, more the surroundings of 2.4 were adapting the same 4-channel plan. We added more channels to 5 gigs, basically utilized available spectrum efficiently, which is very important in my opinion. Then finally, when everything was organized, we turned on HT40 for the 5 gigs. And then this phase, we balanced the AP counts in each APs a little bit by adjusting the power levels there. And the project will still continue, but this is where we are today.
About how much time in between each of the changes? So you did a change?
Yeah, a couple of days always between the change. So we get the daily average, so it has a lot of samples. It becomes a reliable number.
Can I ask whose hardware they were using?
Well, Kes may answer that if he likes, but I'm not gonna touch that topic. Major manufacturer, definitely, yes. So some of the results, how it seems in the SLA table, you can see that before, as Scott was showing, it was a time from before the optimization, there was a lot of red. Once we did the optimization, we got it perform pretty well. So this is the easy way to look at, is it now good or not? Gives the overall view. The improvements we reached were even up to the 700% in throughputs, which is a huge increase by tweaking the parameters only. I think, and this is not the only case where this has happened, I can tell you that. Of course, you can't always guarantee that you will get 700% increases in throughput, but it's common that there are significant improvements.
How did you hold load constant through these tests?
Load was what it was. So basically load, of course, always varies. We have matrices for the load, so we were looking at the aggregate load levels there, and they remained kind of constant. A little bit slightly lower user counts, but it seemed that the users started using more the data. So during this 1 month.
And the cynical part of me looks at this and said, I could figure out how to game your system pretty easy.
Sorry?
I'll just turn on BitTorrent on the post, get big numbers, and show improvement.
So,
I mean, if you can't hold the load constant, your improvements are based on what it was before, what it was after. If I
but we have
turn off BitTorrent
we have
before,
the exact graphs and statistics available for that, so you are really welcome to look at those. So it's a line, load, throughput, packet loss, jitter, utilization, everything mapped out. So it's available, definitely. So sorry that I can't go deeper on that this time. We want to do still the new product introductions, but to summarize this optimization part, every network is different. There are no single tweaks that will solve all the problems. You need to have the data. You need to validate all the changes you do so that you know you are doing the right thing. And once you get the performance up, you will maintain it there by taking actions based on the key performance indicators. This is the key of the philosophy that we promote. Look at the KPIs, managed by the KPIs. It will help you to reduce the amount of complaints from end users, definitely.